The interaction between physics and human societies is profound and multifaceted, shaping our world in ways both visible and invisible. Physics provides the fundamental understanding of how the universe works. And this understanding is then applied to create technologies and solve problems that directly impact societies. Here are some examples categorized for clarity. 1. Energy production and consumption. Example, the development of nuclear power relies heavily on nuclear physics, offering a high energy output. Similarly, our understanding of thermodynamics drives the development of more efficient power plants, both fossil fuel and renewable, solar panels and wind turbines are direct applications of physics, electromagnetism, and fluid dynamics, respectively, to renewable energy sources. 2. Transportation and communication. Example, the invention of the internal combustion engine, based on principles of thermodynamics and mechanics, revolutionized transportation. The development of airplanes relies on aerodynamics and fluid mechanics. Modern communication technologies, from smartphones to the internet, rely heavily on electromagnetism and quantum physics. In the case of semiconductors, GPS navigation systems depend on our understanding of relativity and satellite mechanics. 3. Medicine and healthcare. Example, medical imaging. Techniques like X-rays, CT scans, MRI magnetic resonance imaging, and PET scans are all based on principles of physics. Radiation therapy for cancer treatment utilizes nuclear physics. Laser surgery uses the principles of optics. Advancements in medical devices often rely on materials science and nanotechnology, fields closely related to physics. 4. Agriculture and food production. Example, precision farming techniques utilize GPS and remote sensing electromagnetism to optimize irrigation and fertilizer application. Food preservation techniques, like irradiation, rely on nuclear physics. The development of new materials for packaging also uses principles of materials science closely linked to physics. 5. Environmental science and sustainability. Example, climate modeling and weather forecasting heavily depend on computational physics and atmospheric science. Understanding the physics of pollution helps in developing better air and water purification systems. The development of sustainable energy sources directly relates to our understanding of physics. 6. Military and defense. Example, the development of weapons systems, from artillery to nuclear weapons, is a direct application of physics principles. Radar technology, crucial for defense and surveillance, relies on the understanding of electromagnetism. Ballistics, the study of projectile motion, is a fundamental branch of physics with crucial military applications. 7. Construction and infrastructure. Example, designing and building strong and stable structures relies on the principles of mechanics and materials science. Understanding seismic waves is crucial for constructing earthquake-resistant buildings. The development of new construction materials often incorporates advances in materials science, closely linked to physics.